we already talked about this theorem. We used it already. It's basically if you have a number in front, like the examples that I gave you on this page right here. Remember I gave you 5x to the 7th. What we ended up doing was doing 5 times 7 to get 35, right? When I had 4x to the 11th, we did 4 times 11 to get 44. That's what theorem 5 is saying, really. If you have a coefficient already, you just have to multiply to it. So I'll do a couple more examples, and I will ask you to try you try problems or try these problems as a Canvas quiz for you to see if you can get the answers right. So here it says find each of the following derivatives. So they're using this notation this time. Okay, so they're asking us to find the derivative of 7x to the 4th power. So what do? You multiply the exponent by the coefficient. If you multiply those, you get 28, and you will write down x to the, now you have to go down one, okay? To 4, I'll write it down, okay? For the new exponent, subtract 1, right? Subtract 1 from the original exponent. So if you do 4 minus 1, the new exponent is 3, okay? So that's it. That's how we find the derivative of 7x to the 4th power. Let's keep on going. What about this? Oh no. So guys, if you see a function expression that is not written in a form that has an exponent, but it has a square root, remember, note, you need to rewrite this. Note, square root of x is same as x getting raised to the 1/2 power. You need to know this in order for us to do these power rule problem. If you can't rewrite radical expressions into exponential form, we can't use that power rule, okay? So what I'm finding is this. I'm going to find the derivative of -5 times x to the 1/2 power with respect to x. So the first thing that I did was I rewrote the problem so that the square root expression turns into an exponential term. And why do I need that? Because we need to use the power rule. All right, we're ready to jump into the power rule now. I'm going to multiply the exponent of 1/2 by this coefficient of -5. If I do that, I get -5 over 2. And I'll say x raised to the, all right, what is the new exponent? The new exponent should be 1/2 minus 1. And you will see 1/2 minus 1 very often in this class. So remember that is -1/2. And that is the derivative of -5 times square root of x. Leave it in this form. I am fine with this. Some of you may want to put it, I don't know, some of you guys like the square root form better. I can even see us putting the square root in the bottom of the fraction. So I guess it is the same as -5 over 2 times square root of x. It's in the bottom of the fraction because the exponent is negative. And what I did was I put it back in the square root form. But I will say this is optional. You don't have to. You don't have to. I think I like this one. I like the first answer. But it's also possible if you want to rewrite it, okay? Okay, let's take a look at C. Oh, I'll show you another trick on rewriting. Unfortunately, the x is in the bottom of the fraction. You can't apply the power rule if it's written like that. So what you will have to do is you will have to get this x to the 4th power, who is currently in the bottom of the fraction, out of the bottom of the fraction. And it's going to look like this, okay? This is the same as finding the derivative of negative 45, and you see where I got negative 45 from, right? There is negative 45 right there. But what I'm doing is I'm rewriting 1 over x to the 4th, okay? I'll make a note here. Note. 1 over x to the 4th is same as x to the negative 4th. So I'm going to rewrite that 1 over x to the 4th as x to the negative 4th. So when you have x in the bottom of the fraction, rescue it, okay? Make that exponent a negative and put it next to your coefficient, or what is it called, the numerator, so that it is no longer in the bottom of the fraction. That is necessary for us to use the power rule. Okay, now let's get to the power rule. I'm going to multiply this negative 4 times negative 45. Okay, what is that? Okay, I got my calculator out. 45 times 4 is 180. And when I do negative times negative, that comes out to be positive 180. And the new exponent will be 1 less than negative 4. So if you do negative 4 minus 1, you will get negative 5. If you decide to put this in a different form, you can put the 180 on top of the fraction. But if you want to send it back to the bottom, like say x to the 5th power in the bottom, but that positive 5, the exponent is now positive because we sent it back to the bottom, that's also okay. But I consider that to be the optional rewriting. You don't have to rewrite. I think this answer right there is just as beautiful. Okay, that is correct. All right, so I showed you 3 examples. I also want you to try very similar ones, A, B, and C, and I'll tell you that I'll make this into Canvas quiz for you so that the Canvas will automatically grade it for you. This will be made into a Canvas quiz. Okay, but I don't think this video is so long. It's only been 7 minutes and 20 seconds. I'll keep on going. Okay, I'll keep on going. Now, in general, it looks confusing, but all they're doing is this. If you're taking a derivative of a trinomial, okay, if you're taking a derivative of 3 things inside, like for example, 2x squared plus 5x minus 3, okay, if you're taking a derivative of a trinomial, you can take the derivative of each of these separately and just add them together. That's what they are saying. You take the first, you take the derivative of the second term, and we do this in our head. It's just like distributive property, right? And this is what is called the sum and difference rule, really. So think of it as how we are distributing this operation of differentiation, okay? So I'll show you how to do this. It's very simple. Find each of the following derivatives. So you see how we're taking derivative of not a monomial, but a binomial this time. So what you have to do is, and I will write extra because this is the first example, but you will eventually do these in your head. Okay, so I have derivative of 5x to the 3rd power. And then I have minus derivative of what? 7. So let's start with the first term. I do my power rule. 5 times 3 is 15. And the new exponent is x to the 2nd power because 3 minus 1 is 2. Now what about the red part? Derivative of a constant. This is always 0. By theorem number, I forgot. But anytime you're taking a derivative of a single number, that's going to be 0. Therefore, the final answer is 15x squared. So the 2 lines that I wrote over here, eventually you guys will do these in your head, okay? And I don't have to see, because here's the thing, okay? Whenever I assign problems, people will like to go to like symbol math or like Mathway or something. And they write down meaningless work, like things that are very obvious, but if people are clueless, they'll copy down whatever they see, right? So you don't have to write this much, okay? I know you can do that much in your head. There are more important work that I want you to show me. And when we get to those important work, I'll tell you, I'll make sure that I make it very clear that you show me those work. But the sum and difference, you're separating these, you don't have to. You really don't have to show me all that work. All right, let's try this one. Oh, wow, this is a challenging one. It requires some rewriting. The first term is just fine, but the second term, okay, it's in square root form. So let me start by rewriting these first, okay? Rewrite. So I'm finding the derivative of 24x minus square root of x is x to the 1/2 power, right? So we rewrote that one first, and then plus 5, but you notice x is in the bottom of the fraction. Let's rescue it, let's bring it up. But when it comes up, it's going to have an exponent that is -1. Why? Because when it was in the bottom of the fraction, it had a +1. So if you bring it out, bring it above, or just bring it out of that denominator, it's going to have a negative of that number, okay? So it's important that you rewrite this. So two things that I use to rewrite are this. So note, square root of x is same as x to the 1/2 power. Second, 1 over x is the same thing as x to the -1st power. So review these for me. You've seen these sometime before, but if you haven't used these recently, I want you to remember them, because you need to be able to rewrite algebraic expressions in order to use the power rule, okay? All right, let's get at it now. Okay, so this equals, first, what is the derivative of 24? It's simply going to be 24. I'm sorry, 24x is going to be 24. For linear terms, the exponent of 1 will come down. So you have to do 1 times 24. That's why we have that 24. But you will get x to the 0 power. And that is just 1. That's why I say derivative of a linear term is just going to be that number. So how about, all right, hold on a second. Let me give you a whole bunch of examples. So if I ask you to find ddx of 8x, that's going to be just 8. If I ask you to find the derivative of -2x, guess what? That's going to be just -2. If I ask you to find the derivative of any constant, k times x, k being any constant, that's just going to be k, okay? That's what we just did to find the derivative of 24x down here. Okay, next, I need to work with the second term. Let me first copy down this minus sign though, minus sign. Bring down that exponent of half to the front, 1/2, right, dx. But what is the new exponent? The new exponent should be half minus 1, okay? Half minus 1 is something you will do very often in this class. Just know it. It is -1/2. So the new exponent is -1/2. And then let's go to the next term. Use the power rule. I do -1 times +5. Oh, look, the sign of the coefficient will change. Because I'm doing positive number times a negative number, I will need to write down -5. And x will have a new exponent that is 1 less than -1. -1 minus 1 is -2. So that is the derivative, okay? Wow, this one was the most challenging, because not only that we had to know about the power rule, but we needed to know how to rewrite a radical and a rational expression into an exponential form in order to apply those power rule, okay? So that is it for this video. I'm gonna come back and show you example 4 and 5 in separate videos, okay?